This is a second example workflow designed to partition images into a grid of cubic regions, enabling systematic investigation of spatial dependencies. We begin with a dataset comprising 4 aligned bone section images. Each image represents a three-dimensional micro-CT scan. To subdivide these images into a grid, we again employ the task Spawn Image VOI Grid. This time, we specify a fixed VOI size along with a margin of separation between the grid cells. 9 new runs are generated for each image, arranged in a 3 by 3 grid. Each region can now be analyzed. We first crop the region and then append an automatic thresholding task using Otsu's method. We star the image output parameters to enable a preview within the workflow. Subsequently, we can append any number of quantification tasks, such as fractal dimension or local thickness. All regions within each scanned image are automatically evaluated, producing sequences of output parameters. We can now collect these results and visualize them spatially as an overlay on the original grayscale image. Returning to the workflow editor, we use the Add Sequence task to gather these sequences back to the perimage runs. We also create a mask from the VOI to map the quantified value to the respective VOI region. A pixel formula can be applied to modulate the mask image with any numeric parameter, such as the calculated fractal dimension. The sequence of these modulated images, each containing one grid cell, is then accumulated into a single image, ensuring all grid cells are simultaneously visible for the overlay. The accumulation is constrained to the same bone scan entity, so each bone only accumulates its corresponding results. Finally, a compare snapshot is utilized to visualize this accumulated grid of cells, modulated by the quantified parameter, as an overlay on the original grayscale image. In the sequence selection task, we select the image output from the formula. The snapshot now displays the desired result. The numeric parameters are mapped to a color range, which can be adjusted arbitrarily. The same view settings can be applied consistently across all 4 bones. As previously mentioned, evaluating additional parameters is feasible by appending, for example, a local thickness task. The formula can be modified to utilize the maximum thickness value. Restarting the accumulation now visualizes this new parameter instead. Once the workflow is ready, we can reconfigure the grid to a smaller VOI size and rerun the entire process. 30 regions are now evaluated for each bone. In the 3D view, we can blend the evaluation results as blocks over the grayscale image. Disabling the cutting plane reveals two layers of cells within the grid. Modulating the two images removes the portions of the grid cell that lie outside the bone. Again, this visualization can be automatically recreated with identical settings for all scanned images. Further visualizations can be added by cloning the task and adjusting the view settings.